continuing our discussion with reference to data pre-processing. And we have, for people who are joining just today, we are taking the method of, we are talking about a project that the interviewees have been, asked, and it is continuing. So whatever they have worked on the project, we are continuing the questioning with reference to that project. So here is my first question to Sharat. So Sharat, with reference to your project, can you explain about binning and how did you use binning in your project? And the third part of the question is, why do you need to do binning in the first place?
Thank you, Nitin. And good evening, everyone. So jumping into the character and trying to answer the question here. So the question was, what is about the binning thing and why we need to use that and how it actually helps in dealing with our data. Well, the concept of binning basically is used when we have very large data for interpretation. For example, fuel efficiency is something that I was working on in my project. So that was my target variable, and it's in continuous in nature. Now, if assume that the range of these values is very, very large, the fuel efficiency of a vehicle could be somewhere around 5 kilometers per liter fuel to somewhere around, let's assume that we have a specialist car, very unique car, very special car, which gives us, let's say, 50 kilometers per liter. Of course, it could be a fantasy thing, but let's assume that this is the range of the data that we have. Now, when I try to work on this particular data set, I would have to try and predict this results. And because of the variation that I have, I may not be able to get the appropriate result because of that too much of variation that I have. So what we try to do is try to bin this particular values so that it is also easy for us to apply classification methods and also try and interpret the results in much more homogeneous way. So what we did is we took this fuel efficiency range and we split that. For example, 5 kilometers per liter vehicle till 15 kilometers per liter. This is section 1. We called it as bin 1. You can also give fancy names, but this is one bin. Then from there onwards, upwards, 15 kilometers per liter, upward onwards, till 30 kilometers per liter, this was bin 2. And anything above that was a supercar. It was literally giving us good results. So this way we were able to try and split the range into 3 different categories or bins. Now what happens is when I try to analyze the data with respect to discrete finite set of values, I will be able to come up with much more statistical inferences. It becomes easy for us to understand the data. So that is one of the reasons why we also do binning, especially when we have large range of values. And of course, your business requirements might call in for. Now to do that, we used cut function, very simple function. And we decided to give the customized bin sizes. It's not fixed size. So as you can imagine, I said 5 to 15, the width is 10 units, 15 to 30, that was the width is 15 units, and anything upwards from 30 to 50 was 20 units. So this was a different bin sizes that we were able to give and split our data into buckets.
Thank you so much, Sharat. Bharani, your take on this question and any other approach?
Absolutely. So the project which I worked upon was related to loan default prediction model in the space of bank. And here interpretation is extremely important. When you reject a loan, for instance, of a customer, and if the customer asks for the reason on why you have rejected the loan, you as a bank should be in a position to give a reason on why you have rejected the loan. Given this context, we have proceeded further with 2 algorithms. One was decision tree and another was logistic regression. Both of these have a lot of interpretation capabilities. Decision tree expects the input variables which we are supplying to be in categorical format. And we had numerical columns such as income, age, etc. When you supply these as is to decision tree would automatically convert them, that is continuous or numeric data, into categorical data. It would automatically do that using its own logic. Now, if you don't want some other logic, and if you want your own business logic to be applied in terms of converting continuous into discrete, then you create buckets or bins, and you say that salaries less than $5,000 would be part of category 1. Salaries in the range of 5,000 to 10,000 would be category 2. Salaries in excess of 10,000 would be category 3. Probably this makes more sense for your business. So based on that, you create such buckets or bins rather than leave it for your algorithm to determine automatically different bins of its choice. So this is a scenario where we have resorted to binning. Thank you.
Thank you, Bharani. Thank you. So to sum it up, ultimately, the necessity for binning data is for convenience, predominantly convenience. That convenience could be because you are able to use simpler algorithms. That convenience could be you are able to have different groups of data to understand the various ranges of values. It could be various things. So the context of your answer should be in context with why you have chosen the size of the bin and how it is going to be convenient for your model or the algorithm that you have chosen. So that is effectively the summation of the reason for binning. Okay, thank you.